Hi everyone, so this is the second video that I'm going to make related to the method that I want you to follow when you solve problems in my class. Again, a strategy I want you to use all year long. So, strategy is read the problem, read it again, and underline the numbers and the units, draw a model, list known variables, list the unknown variables, choose an equation to use that would help you find the unknown variables, substitute in your numbers and solve using some math, and then check your work. Make sure your answer makes sense. So we'll do an example right here up on the board to make sure that we know how to solve this kind of problem. All right, so up on the board you can see this problem here says a person starts 2 meters to your right. A few seconds later, they are 9 meters to your right. What is their displacement? Okay, so let's read the problem. Oh, we did that. Read again and underline the numbers and the units. So we have 2 meters, and we have 9 meters. And I think that's all we have. We do have this, we have a few important phrases. To your right, to your right. Okay, so we know that we've had some movement maybe in the positive direction. All right, we also have something about how it happened a few seconds later. So we know which one was initial and which one was final. All right, so let's draw a model. So if I was going to draw this, I might draw something like a number line. Okay, maybe something like that. I have a number line. And I know that this person was here, and then they went here. All right, so that's my model. And I know that there's only been one movement here. My known variables and my unknown variables. Let's see. I know that my initial position was 2 meters. So I'd say xi equals 2 meters. My final position, so xf, is equal to 9 meters. Those are my known variables. That's what I know. All right, and then my displacement. How far did I actually go? That's my unknown. That's what I don't know. So I've listed my known variables and I've listed my unknown variables. Now I want to choose an equation. Well, one equation that we've talked about is displacement is final position minus initial position. So again, not to confuse anybody, but just take a step back looking at what these variables mean. Delta x. Delta means change, x means position. So literally this means change in position. That's what displacement is how much did your position change? If I want to know that, I need to know where did I end and where did I start? And I'm going to subtract those two things. Final position, initial position. So now I'm going to substitute and solve. This is 9. This is 2. Delta x equals 9 minus 2. Well then, delta x, my displacement, is equal to 7. And that's meters. All right, so I substitute solve. Now I'm going to check my work. Does it make sense for this person to have gone 7 meters? Should I have a positive number? Does 7 seem like a good quantity to have? Yeah, I'm dealing with numbers that are in the single digits. So if I had a number that was really big, like 100, my math was probably wrong. And then I know it should be positive because I moved to the right. And my units are correct. I have meters because the problem gave me meters. All right, that's how we can use this list of steps here to make sure that we get our problems correct and make sure that our problems are clear. Make sure that we have a good drawing, make sure that we've listed our variables, make sure that we've shown our work. Okay, so as your teacher, I know that you actually understand how to solve these problems. All right, I hope this was useful.